Okay, a couple of examples on using an integrating factor. So the equation needs to be in the form dy dx plus py equals q, which this one quite clearly is. And the integrating factor is e to the integral of p dx. So in this example here, p is equal to minus 4. So to find the integrating factor, so f of x is equal to e to the integral of minus 4 dx. If you integrate minus 4 with respect to x, you get minus 4x. Don't worry about plus c's in these either. So you get e to the power of minus 4x. And then I multiply through by that. So you get e to the minus 4x dy dx minus 4e to the minus 4xy is equal to e to the x times e to the minus 4x. And then this left-hand side should reduce quite naturally to a product that's been differentiated. And that's your f of x. This bit here is your f dash x. So I'm literally doing d dx e to the minus 4x. And don't forget the y as well. So there's your v, in fact it's round the wrong way, isn't it? But there's your u to v dx plus v du dx. So you could just check that this does differentiate to this, but it should do. It's worth a check just to make sure you haven't done anything wrong. And then that's e to the power of minus 3x. And so integrating both sides, e to the minus 4xy equals the integral of e to the minus 3x dx. This goes to minus a third e to the minus 3x. So minus e to the minus 3x over 3. And I do need my plus c in here. And then to tidy this one up, I can multiply through by e to the power of 4x. And then that makes that y equals. So y is equal to minus e to the x over 3, sometimes by e to the power of 4x, plus ce to the power of 4x. But don't forget to put your constant in as soon as you've integrated, because it needs to sit there in that final equation. So that's that one. Let's do another one actually. Let's just check the time. I need a better phone or a webcam, probably. How are we doing? I think we're okay. Right, so next one is cos x dy dx plus 2y sin x is equal to cos to the power 4 of x. Right, this isn't in the right form because I need it as dy dx plus py equals q. And so I need to divide through by cos x first. So do make sure you're in the right form before you start. And so sin x over cos x is tan x. And right hand side becomes cos cubed x. And then the integrating factor, so f of x is equal to e to the integral of p, which is 2 tan x, dx. Tan integrates to ln of sec x, so this is equal to e to the 2 ln sec x. I can bring up this power, so that's equal to e ln of sec squared x, and then we've got inverses, so that goes to sec squared x. So my integrating factor is sec squared x. So sec squared x dy dx plus 2y sec squared x tan x, and cos cubed times sec squared. Sec squared is 1 over cos squared, so it's just going to give you cos x. And so d dx of sec squared x times by y. And again, you could just do a quick check to make sure your sec squared x differentiates to sec squared x tan x times 2, which it does. She says convincingly. Cos goes to sin x plus c. Remember, if you differentiate sec x, you get sec x tan x. So, yeah, try to convince you that line is correct slightly better. And I've lost the plot now. Right, so now I need to integrate. Oh, sorry, that's the cos x still. So d dx sec squared xy equals cos x. Integrating both sides gives you sec squared xy equals the integral of cos x, which is sin x, plus c. And then times into 3 by cos squared. Y is equal to cos squared x, lots of sin x plus c, and just be careful that plus c, you need to times that by the cos squared as well. So hopefully that's enough for you to have a go at a few now.